My name is Dr. Ahmed Arslan, and today I am going to discuss parameters of argon laser. So let us first talk what is argon laser. Argon laser is a type of gas laser that uses argon gas as an active medium to produce a highly coherent and intense beam of light. The laser emit light in the visible spectrum, typically blue-green light at the wavelength of 488 nanometer and 514 nanometers are used. So what are the principles? The principle of argon lasers involve excitation of argon gas atom, creation of an invariant population, amplification of light through stimulated emission, and generation of a coherent and intense laser beam. This is a schematic diagram of how a laser beam is created and then emitted through a laser probe. Properties of laser light: it is coherent, monochromatic, co-laminated, it has constant phasic relation and ability to be controlled in a short time interval. Ophthalmological uses: argon laser has several applications of ophthalmology owing to its precise control and delivery of energy. These include retinal photocoagulation, laser trabeculoplasty, peripheral iridotomy, and treatment of retinal tears. Parameters include wavelength. The argon laser typically emit light into primary wavelengths 488 nanometer blue-green and 514 nanometer green. These wavelengths are in visible spectrum and are commonly used in ophthalmological procedures. Power output: it varies from few milliwatts to several watts. Parameters में सर next pulse duration. Argon laser can be operated in continuous wave mode or pulse mode. In pulse mode, the pulse duration, also known as pulse width, can be adjusted to control the duration of laser delivered during each pulse. This parameter is important for optimizing the treatment effect while minimizing damage to surrounding tissues. Spot size refer to the diameter of laser beam at the target site. It is also adjusted to a desirable limit to minimize collateral damage to adjacent tissues. Spacing: it is the distance between consecutive laser shots applied to any tissue. Maintaining proper distance between the burns is important to maintain tissue integrity and function, especially in case of retina. Beam delivery system. The beam delivery system includes the components such as mirror, lenses, and optical fiber that control the direction and focus of the laser beam. In ophthalmological procedure, specialized delivery systems are often used to precisely target ocular tissues while minimizing interference with surrounding tissues. सर इसमें जैसे स्लिट लैम्प या जो लेंस हम फोकस कर रहे हैं, बीम को फोकस करने के लिए यूज़ कर रहे हैं, वो आ जाते हैं. Parameters in pan retinal photocoagulation. In pan retinal photocoagulation procedures, a retinal burn diameter of 400 micrometer is usually desired for PRP, keeping the correction factor of a particular lens in mind. Duration is usually kept at 0.05 to 0.1 seconds with argon laser. Power should be sufficient to produce only intense burns, usually around 200 to 250 microwatts. Parameters further are spacing: burn should be separated by 1 to 1.5 burn width to achieve optimal results. The extent of treated area in initial treatment session should consist of 1500 burns to avoid complications. However, 2500 to 3500 burns are required for mild proliferative diabetic retinopathy, 4000 for moderate, and 7000 for severe proliferative diabetic retinopathy. This is an image showing a retina that has undergone pan-retinal photocoagulation. Parameters for diabetic macular edema. For diabetic macular edema, focal or grid pattern lasers can be applied. For focal application, argon or diode burns are applied to leaking microaneurysm 500 to 3000 microns from fovea, usually a spot size of 50 to 100 micrometer, with sufficient power to obtain grayish reflex beneath the microaneurysm. Grid patterns are used in macular areas of diffuse thickening no closer than 500 microns from fovea and 500 microns from optic disc. A spot size of 50 to 100 micron and duration of 0.05 to 0.1 second is enough to give a mild reaction in a grid pattern. It shows a focal pattern. Laser is applied to area where there are leaking of microaneurysms. This is a grid pattern applied in case of diabetic macular edema, and this is pan-retinal photocoagulation laser pattern. Parameters for trabeculoplasty: spot size of 50 micron is selected, duration is usually 0.1, power in milliwatts is 200 to 800, number of spots per quadrant usually kept around 20 to 25, wavelength argon green is used, and Goldman contact lens is used, and topical anesthesia is provided to the patient. This is an image showing laser trabeculoplasty. Laser beam passes through a lens and then acts upon this trabecular meshware to make it easy for the filtration of aqueous humor across this trabecular mesh. Parameters for peripheral iridoplasty: it depends upon the color of irises, light irises and dark irises. Spot size is usually kept at 50 microns in both cases. Spot duration 0.2 seconds for light irises and 0.02 to 0.05 in dark. Power is kept as 1000 milliwatts. Number of spots per quadrant is 15 to 25 in case of light iridii, and in case of dark 25 to 100 can be used. In both, argon laser in green spectrum is used, contact lens Abraham and for use for light iridii, and Weiss for dark. And treatment with pilocarpine and aproclonidine or brimonidine before applying the laser is usually given to the patient. Thank you.